In this video, we're going to go over integrity as it relates to database security. So one threat to integrity is SQL injections. Now, SQL injections are malicious code that trick the database into executing unintended commands. This is the number one form of compromise in most databases that have been compromised. And this is typically done through inputs that users have access to where they can type in free-form data entry and it manipulates the data to do something that is unintended. There are several forms that this can be done, such as string concatenation, line commenting, block commenting, or query chaining. I'm not going to go over all the examples on this slide, but I'll walk through a couple examples on the next few slides. So the first example is SQL injection using dynamic queries. So for example, let's say we had a form where we're asked to enter our username and password and then click the login button to log in. What we're going to do is type in our username, password. So after we submit this form, in the backend it's going to interpret this as a query by counting the number of users where the username equals whatever the user typed into the user input and the password equals whatever the user typed into the password input. So for example, if a user typed in Ormond and my secure password, the query behind the scenes would say select count star from users where the username equals Ormond and the password equals my secure password. If this is the correct credentials, it's going to result in a successful login. On the other hand, let's say we had a user that tried to manipulate this form to do something other than intended. So instead of typing a valid username and password, they type in quote or 1 equals 1 pound sign. So if we go to the bottom right here, we can see that the query now is interpreted as select count star from users where username equals, and then it's going to start looking for the username, but with that initial quote, it's going to close the username, so it's going to say where the username equals nothing or 1 equals 1, and then it has a pound sign at the end to comment out the rest of the query. So it's either find a user that doesn't have a username, or where 1 equals 1, find all those users. So when does 1 equal 1? Always. So this would return a count of the total number of users. So what's going to happen is it's going to result in a successful login because it found more than 0 users that were associated with the username that was typed into the form above. Alright, so here I am back in my server. I'm going to demonstrate an example of a form that I've created that allows for this SQL injection. So as you can see here, we have a username named bbaggins with a password that's encrypted. So if I were to type in the valid credentials of bbaggins and then one password to rule them all with the first letter of every word capitalized, I go ahead and click login. So as we can see here, it says the credentials you entered are valid, and then we're asked to try to log in without using valid credentials. So what I'm going to do is try to log in as a user without providing valid credentials. So we'll go ahead and end the prior string, and then we'll say or 1 equals 1, and then I'll put a pound sign. I'll just type in some character in case the form actually checks to see if something was typed into every element. I'll go ahead and click login, and as you can see here, it says you successfully logged in without providing legitimate credentials. So let's look at another example of a SQL injection. This one is going to be using chained queries, also known as a stacked SQL injection. So here we're going to provide a supervisor ID, click the submit button to see the employees that this supervisor is over. So the query on the back end says select star from employee where the supervisor equals whatever's typed into this form. So for example, if the user types in 3, it's going to select star from employee where the supervisor equals 3 and will return all the employees that are supervised by this supervisor. Now, what if someone were to continue this query and say semicolon and then delete from some table or drop a table or any other query that they want to execute? On the back end, it would say select star from employee where the supervisor equals 3, and then it would run another query saying delete from security user. So it would still display the results that we were expecting, but additionally, it would delete all the data from the security user table. All right, so here I am back at the server. Here's an example that I built based on this exact same illustration. Now we have a drop down, so we can't just do freeform entry. So I'm going to go ahead and inspect this code. And over here on the right, you can see what is available. So by picking Lawrence Haley in the drop down, it will select the value of 2. So this is where I'm going to go ahead and just manipulate this. So I'm going to say 2, delete from security user. And this should pull all those that Lawrence supervises as well as delete all the users from the security user table. So after I've changed this, I'm now going to go ahead and click the submit button, and you can see that it has pulled all the employees that are supervised by this employee, as well as says you successfully deleted all the security users. So how do you protect against SQL injections? So some of the countermeasures are prepared statements. So prepared statements, basically what we're going to do is store all the form entry pieces into variables. So for example, let's say we had a form where the user had to type in an employee ID, a first name, and a last name. We're going to store these in variables. So employee ID is equal to 17, first name is equal to Billy, and last name is equal to Blue Jay. Now the query, instead of actually putting these values directly into the query, I'm going to just use question marks. So as you can see here, it says insert into employee, the 3 columns that I'm going to insert these values into, and then I'm going to say values and then 3 question marks. Then I'm going to prepare my query and execute it. And inside the execute statement, I'm going to pass in what I'm going to substitute those question marks. So in corresponding order, employee ID is going to be substituted for the first question mark, first name is going to be substituted for the second question mark, and last name is going to be substituted for the third question mark. In this way, I can protect against SQL injections because it is going to literally interpret all the data as is rather than as a continuation of the SQL string. I could do the same thing for a select statement. As you can see here, I say select star from employee where first name equals question mark and last name equals question mark. I've defined the variables of the name I'm going to insert, and then in the execute, I provide the first name and last name. The first name is going to correspond with the first question mark, and the last name is going to correspond with the second question mark. Now, there are other forms of writing queries in PHP specifically. You can use MySQL query and MySQL multi-query. You should never execute multiple queries if you can just execute one query. This would protect against those stacked SQL injections that we talked about just a minute ago. Additionally, you can protect against SQL injections using stored procedures. So you can also prepare statements in stored procedures, just like what we did with PHP on the previous slide. This time, I'm going to create a procedure that is going to take in 2 values. It's going to take in a table and it's going to take in a column. And then I'm going to set a variable of s as concatenate the select column from the table. So it's going to build a query and store it in a variable. Then I'm going to say prepare statement from that variable. And then finally, I'm going to execute that statement. Then I'll deallocate the prepare statement. So essentially what this is going to do is whatever table and whatever column I pass into this query, it's going to pull that column data from that query. Aside from SQL injections, we also have another threat of the lost update, which basically means that when I have multiple people accessing the database at the same time, it can result in data loss because one thing cancels another. So take, for example, we have John and Jane that are trying to purchase seats at some theater. So John reads the record and finds that there are 25 seats available, and then Jane reads it right after and sees that there's also 25 seats available. So John decides to purchase tickets for 4 seats, and then there are now 21 seats available. And Jane at the same time purchases 6 seats, which indicates there's 19 seats left. So the lost update here is that the 25 minus the 6 resulting in 19 completely overwrote the 25 minus 4 equals 21. So rather than having 15 seats left, we have 19. That is the case of the lost update. So how do we protect against a lost update? We can use locking mechanisms, which basically this is the process of managing simultaneous operations against the database. So it's basically going to lock certain resources until a user has given up access to those resources for another user to use them. So for example, if John wants to get those seats again, he can get and lock seats A7 and A9 so no one else can reserve those seats until he gives up those seats. Jane, if she comes in and sees that they were initially available and tries to get those seats A7, A9, but John got them first, Jane would see that they are now locked. Now, if John cancels the seat transaction, the seats would be unlocked and Jane could then get and lock the seats. The problem with locking mechanisms is the threat of deadlock, which is basically an impasse where the results when 2 or more transactions have locked common resources. So for example, if John gets and locks the record for nuts, and Jane gets and locks the record for bolts, and then John needs the bolts and Jane needs the nuts, both of them have locked each other out from getting what they need, and it results in a deadlock. Another thing that can be done to ensure that deadlock doesn't happen is using versioning. Now, versioning is where each transaction can attempt an update, but the system will reject or roll back an update if there is a conflict. So for example, if John and Jane both own a bank account together, let's say they're husband and wife, and John reads that they have a remaining balance of $1,000, and Jane also reads that they have a remaining balance of $1,000. Let's say that John began to withdraw $200 from the bank account, and then Jane attempted to withdraw $300 at the same time. John's $200 would be committed, and Jane's would be rolled back, and she would have to restart the transaction all over again. A lot of times where you see versioning is where companies have these special deals that they publish out, and then everyone rushes to their website and tries to purchase something. But what happens is when people initially get there, everything looks like it's available, but as they go through the checkout process, some people aren't as quick enough, and so by the time they get through the transaction, there's no more seats available or nothing else available, and so they're rolled back and told that everything has been taken. So which is better, locking or versioning mechanisms? Take a minute and think about this answer on your own, and then come back for the discussion. All right, welcome back. So there isn't necessarily a better one. It really depends on the need of the database. So for example, versioning mechanisms ensure that you didn't sell more than you have available in stock. Locking could ensure that you only give specific people access to the resource at a time, so it doesn't result in major issues. So for example, maybe it was something in healthcare and you only wanted one person to have access to a specific system at a time. This would ensure that nothing negative could happen unless that one person messed it up.